Right. Let's see, these things are the number of partitions. I wrote the explanation of what I'm doing in the description of the stream. By the way, cache of the number of partitions existing of G groups when starting with top groups. And adding depth new elements. This is almost the same description, but then decoded from the table. Returns a reference into the cache. For a given, well, I won't repeat the description, I guess. I'll just repeat. I think I should not abbreviate the G here. Let's rename G to groups, as in number of groups. Number of groups is maybe a bit too long. How about group count? Group count. Here I'm using groups. Okay, let's stick at groups. This line looks a bit mysterious, so I probably should add a comment for it as well. Yeah, for example, here we have table 2, and you do not want to store these zeros, and also not the first column. So the whole table is shifted 1 to the left, so these row of zeros drop out. And we have only 2 arrays. It's an array of an array, not an array of an array of an array. So the internal array stores all these, stores this whole triangle here, counting as index 0, index 1, index 2, index 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, etc. Which then gives rise to this expression here for the triangle. And this is basically the left shift. Now it speaks for itself. So this detects if we are on a 0. So if we're too far to the left, or if we are in the upper triangle of zeros. Also renaming this groups. What I need is to know how many partitions are below the substitute G with the groups. I need to know how many partitions there are. I have to make this. Hey, fat man. Mosh. You were such. It's so long. Every stream. You can vaguely understand why it is interesting to watch it live, but to watch it non-live, that would be very long. Yeah, these tables are a bit vague. I would like to show again the picture I have on my whiteboard. So maybe I should just redo that here for the people that are now watching, or is everyone a regular and they already know? So the idea is, if we have a single element, we just have partitioning. Well, you cannot partition it, it's just a single element. If we have 2 elements, however, we can make use of the fact that we already know how to partition one element. Namely, we can either add a new element to the set that we already had. Let's do it like this. So now we have a single set with 2 elements, or we can create a new set. This is a set now. It's not clear. Is this clear? It would only be clear because there's lots of spaces in between. Okay, let me do it like this. I mean, it's just a notation, so I make it up. Make it up as I go. It's okay. So now the clear trick here is that either you add it to the set you already have, or you create a new set for the B. And then the next step is when you add a C, either we add the C to the existing set, or starting with a B, we create a new set. Or, so this one belongs to this one. In this case we have, well, we added the C to existing set A, or we added to the existing set where B is in, or we create a new set just for C. And I even want to add one more, and then I have 15 things on a row. So and the next line is 52 long. let's stick at the maximum is 15. So in this case I'm gonna have ABC with the D in it, or ABC with the D, with the D in on its own, or ABDC, can't type, or ABCD, or ABCD. Right, so starting with this one, we can either put the D in the same set or in its own set, and starting with this one, we can either put the D in together with the AB, or together with the C, or on its own set. And then here I get ACD, B, ACBD, and ACBD, and then the last one. Now this was the second last one, so the A, comma BC, ADBC, ABCD, and ABCD. And now the last one, ABC, is AD, B, C, or A, B, D, C, or A, B, C, D, or A, B, C, D. Yeah, well, so maybe you should put a vertical bar where it gets split, like here because these two are derived from this one. So I put a vertical bar here to make clear this, that now we start the things that are derived from the next one above that. And then here we get the same thing. I already put the space in it, but yeah, well, now I need another. Okay, I think that's enough. So there's a 15 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, sorry, yeah, 13, 14, 15. Right, so that's correct, and so on. So you can see that the number of partitions after adding D is simply one more than put it this way. So if if I have two groups here, so two sets A, B, and C. So it just doesn't matter that it's A, B. It could be A, B, C, D, C, D till Z, till Z. The only thing that matters is we have 1, 2 sets. Then I can add the next element either to the first one or to the second one, or I can make a one of its own. So since I have two sets here, we end up with 2 plus 1 derived partitions. And here it doesn't matter that this is different. It's ACB now instead of ABC. The only thing that matters is that there is the number of sets that we have. We have 2 sets here, therefore we get 3 derived sets. We have 2 sets here, therefore we get 3 derived sets. Or partitions, I must say. Sorry. We have 2 sets here, there we get 3, so 2 plus 1 is 3 partitions derived from it. Here we have 3 sets, therefore we get 3 plus 1 is 4 partitions derived from it. Right? Therefore, what I did here is I make a table where I have split up the number of groups that we have. So in this case we have 4. I'll just start at the top. We have one element, and that would be depth 0 here. And we have a single set. I call it groups here, but it really is a set. It's not a mathematical group. So I use a group and a set interchangeably here because it's not, there is nothing to do with mathematical groups here, so it doesn't really matter. Okay, so we have A here as on its own. It's one set. That would be this one. Depth 0. There is one partition. Oops. There is one partition that has one set. There are no partitions that have more than one set, obviously, because we only have one element. One further down means 2 elements. We have one partition with one set, and we have one partition with 2 sets. That's this. There is one partition with one set, and there is one partition with 2 sets or groups. And then below that we have depth is 2, so now we have 3 elements. We have one partition with just one set, ABC all in the same set. We have 3 partitions with 2 sets, namely 1, 2, 3. Those 3 have 2 sets each. And then we have one partition with 3 sets. That would be this one. Yeah, and finally, which I draw out here, we have for 4 elements, we have respectively 1, 7, 6 and 1 partitions with 1, 2, 3 and 4 sets. So that is, this is the having 1 set, and then we must have 7 with 2 sets. Well, that's 1, 2, 3, not this one, this has 3, 4, 5, skip this one, 6, 7, and this is not 2, not 2, not 2, no, not 2. So that's 7 indeed. And we must have 6 with 3 sets. There's 1, 2, 3, 4, 5, 6. And then finally 1 with 4 sets. See, so that's how the table is built up. And we can calculate this table now. If you look at how these things were generated, then you can easily see that each number here is the number in the column, so the number of groups multiplied with the number of sets that we derived from, plus the number of the number of partitions. So yeah, this inner block is the number of partitions. So this number, the number of 6 partitions, come from the fact that there is, with 1 element less, 1 partition that has 3, that's this column, sets, namely this one. And then we get, as a result from that, we get 3 times 1 is 3 new partitions, namely these 3. My mouse is broken. Yeah, so we have one set with we have one partition with 3 sets, and I can put D in the first one, the second one, or the third one, and therefore I get 3 new partitions from that. Plus this number here, namely the number of, we have 3 partitions with 2 sets with 1 element less. Let me think. Yeah, because I'm only trying to find the number of partitions with exactly 3 sets as a result. So if we start with the ones that have 2 in it, and that would be this one, and this one, that's this 3 here. Each leads, so they have 2 sets, right? So each leads to an if we add the element in its own set to a partition with 3 sets. And this one leads to that one, this one leads to that one, and this one leads to that one. So we just have those 3 lead to 3 additional partitions with 3 sets. So this 6 is 3 times 1 plus 3 is 6, and that holds for the whole table. For example, 3 times 6 is 18, plus 7 is 25, or 2 times 7 is 14, plus 1 is 15, and so on. Now this table here is basically the exact same thing, but then we do not start with a set with a single set, either this one or this one or this one. We start with one that has 2, for example this one. We have 2 sets. The result is then the table that you get from this. You start with a 1 here instead of a 1 here. Now we have one partition with 2 sets. That's all we have. And now we're applying the same rule. And it's 2 times 1 plus 0 is 2. Or this one, 3 times 5 is 15 plus 4 is 19. So the rule is the same. You can generate the whole table from just this first row here. Then if we add all the numbers in one row, for example 1 plus 15 plus 25 plus 10 plus 1 is 52, that gives us all the partitions, because these enumerate the partitions with a given number of sets. But if we're just only interested in the number of partitions and we don't care about how many sets there are in, then we just have to count them all. So in this case we got 1 with 1 set, 7 with 2 sets, 6 with 3 sets and 1 with 4 sets, and in total that's 15. Okay, that was all for the viewers in explanation. So I hoped you liked that I explained it. This implements that formula. So we do groups times the value in the table directly above it. Directly above it means subtract 1 from depth, plus the value that is diagonally above it. So table value with depth minus 1 and groups minus 1. That would be diagonally. So V is, if we want to calculate is 9, then we get from the table depth minus 1, groups minus 1. V is this 5 here. G is 4, and then just depth minus 1 in the table is 1. And we do groups times that table value plus V is 9. So that's 4 times 1 plus V, which is that one. Okay, and then we have some certain special cases where we need a 0, and zeros are not in the table, so we have to take care of that there are that they appear here in the code without looking them up in the table. Although on the other hand, I think this should already take care of it, so maybe I can remove this and just call table anyway, and then we would get the 0 back from here. That should happen, I guess. So suppose groups equals top groups, and we call this. Then the result is that groups minus 1 becomes less than top groups. So this is true, and therefore we return 0. I'm caching it anyway, so maybe it's easier to read, because this would be a speed up, which I think is not necessary. So I'm just going to replace this with that table value. And now you literally see what we did. So the diagonal value plus groups times the value right above us. Okay, but what we really need is the sum. So I want to make a new function which gives me the number of partitions yeah, I'm using ints, but actually it's probably going larger than an int very quickly. See, the number of groups can be an int, and the number of sets can be an int or not. Yeah, it can be an int. I think only the number of partitions not. Let's call this the partition count type. And that can be unsigned, I guess. Let's just take an unsigned longer now. Now this array is storing a count, right? Partition count. It's the number of partitions with a given distance to, what was it? Yeah, that's what it says here. It's the number of partitions that you get starting with a single partition with a certain number of sets and then add a certain number of elements. But it's anyway, it counts the number of partitions. So that is then the same here. But these can be ints. Hello, Zinny. Yeah, hello everyone else. Gamer was leaving. Okay. Sorry that I did not respond. What is this? I'm having an NP here function called NP, which stands for number of partitions. Yesterday I felt like abbreviating everything, but it's a no-no. So I'll change it, and it's a number of partitions, but it's different from the function that I'm making now. This is like a reference to the cache. But okay, that stores the number of partitions per etc, etc. I'll just write it in full, I guess. No, it's too long. Damn it. It's way too long. You know what? You can use overloading. I just call it number of partitions. Well, can you use overloading if the return type is different? I don't think so. This returns a partition count reference, and then my new function returns a partition count type, but not a reference. I don't think that's allowed. Let's try it. So here we do not pass the number of groups. I really have to change groups into sets, because now it eternally is bothering me. The only problem I have with set is that it's only 3 characters long, and it's equal to the standard set. So it's harder to grab on. Need something longer than a set. Yeah, well, I don't know. Let's keep group then for a while. Okay, so this function is exactly the same as table, but it returns the sum. So we just have to run over all the groups, on the number of groups. We don't know how many groups there are, right? Although, kind of do. Yeah, I can never go higher than the maximum value, which is the total number of elements. The total number of elements for the whole program, the way that it was compiled. So the number of groups always must be less or equal than the number of elements. Talking about mixing up elements and groups. Plus plus groups. And then I'm going to let's call this a sum. So sum exists of terms. So one term is then a call to table. Top groups, comma depth, comma groups. And then if that term is a 0, then we're done, because then everything else will be 0 as well. I'm incrementing groups. So by the time we encounter a 0, then if we increment groups further, we'll just, you know, everything to the left is zeros, infinitely long, only zeros to this side. So if we encounter the first 0, we might as well stop. Or we stop when the table ends. I could also stop when we see a 1, because every table ends in a 1. But on then I see this one, I might get confused, right? So that would be a special case. Let's just stop when we see a 0. And of course, if it's not 0, we add it to the term to our sum, and then in the end we return the sum. I don't think there's a real need to cache this one. I mean, table is already cached, so it's just a simple loop. Let us add this as well. Now I think about it, I want to really reproduce my nice tables here, so I'm going to print the depth in front of it. And let's use a width with that, as in same width also. Well, depth is small. I use a width of, no, it's not necessary. Depth is always less than 10, isn't it? No, it's not. Okay, let's use a width of 2. So we can go up to 99, which we'll never ever do. So I print here the number of groups, that will be the title. And then we run over the number of depths. So I want to print here with the width of 2, the depth. And then we need also an extra 2 spaces here. And this one is print with a width of 8, so that should already work then. I renamed it, but not there. Number of partitions. Yeah, that works. Can even return a different type then. See, so now we have the depth count here in front of it. Depth, groups, and partition count. And I want to follow that with the sum. So here, for example, I can just print equals, and that means if you sum it all up. Then we print the number of partitions for that given. Top groups and depth. And clearly that's all zeros all the time. Well, not really. It got confused by this zero. Sees this zero and it thinks, oh, break, we are at this zero. Same problems before. Probably wise to just simply start at a column that is non-zero. So the first one does not have to skip anything, and then we want to skip the first column, the second table. Kind of logical, now I think about it. Top groups means the number of groups that our top node has. So it doesn't make any sense to look for anything less. So we just start looking for the number of groups that are in the top group. Which then removes all our zeros. Well, I don't really need to see them, but the sum is still zero. That's really annoying. What's going wrong here? I think I added it to the wrong loop. Of course, I have to change this function here. This is where the break is. Oops. That should start at top groups. Now it works. Okay, so vertically, if we add this, 2 plus 1 is 3, okay, 4 plus 5 plus 1 is 10, and I believe it already. The rest is probably okay. Yep. Now the funny thing is that we made the new series. So this series that we get here equals this one. Now we have 1, 2, 5, 15, 52, 203. 1, 2, 5, 15, 52, 203. Recognize these numbers as well. So that's really just this sequence. And now we have a new sequence. This one and this one and this one. We have an infinite number of new sequences. Let's see if the integer sequence database knows this sequence. Quickly moving it over here so I can still see it while I type it in. There's no search here, I have to go to the beginning. Okay, so 1, 3, 10, 37, 151, 674, Number 3263, comma 17007. Well, that should be enough. Those are the two bell numbers. So the previous one we had was the bell numbers, and these are the two bell numbers, which is probably exactly what's, well, the same problem that I had. So yeah, the next one is 948, and yeah, they are the same. What? They are not the same. Huh? I think this is correct. It should be 562,595. And what I have is 562,594. So this is one too small. And the reason is, I guess, that we just stop here. No, really, this is just 1, 1, 1, 1, 1, 1, 1, 1, 1, and that last one drops off. There is no last one here. And that means we just went too far, I think. This bottom row should not be printed when we are talking about 10 elements. It probably does not make any sense. We should stop here. Yeah, we should stop here. Yeah, okay, that actually makes sense. So let's do that. So the loop that runs over the number of depth should have an end where we subtract the number of groups from depth, something like that, number of top groups. Let's do it with an assert. So if groups, if depth gets larger, so some formula is larger than the number of elements, then I want to assert. So actually I want to test that it is less than or equal the number of elements. And if depth gets too large, if depth is too large, then it's wrong. So we must do something plus depth, and then as depth gets larger and larger, and sometimes we fail here. And then this must of course be linear with depth. The maximum value of depth must be less when top groups grow. So this is also a plus. And now we're just plus or minus 1 off. And I think I had my number of elements currently were 10. Yep. And then in the first table, I must run the first table of top groups is 1. 9 was correct. So 1 plus 9 is still equal to that. So I think this is the assert that I want. And now we crash right after this one. So the first one is correct, and here we print the last line and then something goes wrong. So the assert is correct. And then we'll make sure that we won't do that by less than or equal, and then minus top groups. So now it works. Yeah, I'm actually looking at the chat. Hello everyone. Milk Coco asks, why do you dislike post incrementation? That's because it doesn't matter when it is built in. But if say you have sorry, if you have an iterator, it does matter. So say you write an iterator. The iterator has internal state. I don't know, state. Now we write the pre-increment. Both pre and post increment must return a reference to the current. No, not true. The pre-increment returns a reference. And the post increment must return iterator by value, because it must return the previous value, right? So this one ends with return this. Now we can simply increment our state. Yep, this is a pre-increment. We have an iterator. It has a state. We pre-increment the state, and then we just return a reference to our current thing, and whatever you get is already incremented. But the post increment must return the previous value. So somewhere in here we have plus plus state, but you can so plus state plus plus, I don't care, there's a built-in, same thing. But what we have to return is the previous value, so not a reference to the incremented iterator. So we must return the previous value, so we must make a copy. So post increment must make a copy of the iterator, then increment itself and then return the copy. Therefore I dislike post increment, because it's clearly slower than pre-increment. And if you dislike it for iterators, then you get used to the pattern. Because a post increment would make a copy that would call this one. That would be slower. So I get used to the pre-increment because it's faster. And therefore I also use it for build-ins when it doesn't matter. And so even if I make this now an int, still alarm bells go off in my head if I see I++, even though the assembly code would be the same. Right, well, I hope someone liked that answer. I don't know if the mild Coco was still here. That's something that is always extremely difficult to say. What I see, he already left, but okay. It's another reason why I don't like answering questions like this. It takes a few minutes, and then I cannot check if that person that asked the question, he's still here. You see, YouTube is not showing me if you leave or not. So, and people are, the average view time is currently 1 minute. So by far most people come here and then they leave again. So if I don't look at the chat for 2 minutes and then answer a question, there's a high chance that I'm talking to nobody, if you understand what I mean. But yeah, it's a sad thing, because sometimes I'm really willing to give an explanation as long as I know that the guy who asked it is still there. But let me continue with my program. Table. Okay, so now I have a function that gives me the number of partitions given the top group and the depth. For example, we are here and I want to know how many partitions will be derived from that, assuming we have 4 elements. Well, the ones that are derived from that with 3 elements is this, and the ones that derived from those with 4 elements are those, which is 10. Well, then I look in my 2 table with a depth of 2. 2 table, depth of 2, 10. So now, given the number of elements, and given the number of elements in the current partition, and given the number of groups in the current partition, I know how many partitions are going to follow from that. And that will allow me to decide the weight, or rather the number of partitions that belongs to each branch. For example, in this case, if at the moment I'm here and we have 4 elements, then I know that this branch will end up in 5 different partitions, and this branch will end up in 10 different partitions. The reason being that this one has 1 set, so I look in this table at depth 2 is 5, and this one has 2, therefore I look in the 2 table at a depth of 2, which is 10. So then I add those 2 numbers, 5 plus 10 is 15, I generate a random number between 1 and 15, and if it is 1 to 5, I take this branch, and if it is 6 to 15, I take this branch. Having taken that branch, I'll then do the same thing for the next branch, and the next one until we are at the end. And then I have my uniformly distributed partition. So that's the goal, and that's what I'm going to try to code. Well, that means that at any given moment we must have a partition, and given the partition I must be able to see how many groups it has. I don't think I need this anymore, this is just printing the tables. Let us begin with a partition. with a single element. Let's call this partition current partition or the root. Current root. I know, man, I just make it up. And it must contain A. Just check if that is working for us by printing it. Then I need to include partition. I don't think this will link actually. It's worse than that. Oh, I cannot make that. I can only make a group with A. Sorry. So I want a partition with a single group. And then the group exists of only element A. Really? Oh wait, yeah, I can only make an element like that. Absolutely horrible. Hopefully this works. And indeed it doesn't link. The reason it doesn't link is because I have to also include now probably almost all the other files. At the very least partition, but probably also element. Let's just try it one by one. Partition.cxx and element.cxx and group, of course. Only find reference to G scores, so you need scores as well. Score.cxx. Only find reference to partition iterator. Ew. I can just edit this because it's up there already. Partition iterator is inside this one, I think. Already saw brute force. No, this is the partition iterator. I probably need all of them. What am I thinking? Well, there's... No, I don't need brute force. Why would I need brute force? Am I brute forcing something? But who cares? Yay, we have... It took a while, but we finally did it. One partition with one set with one element. Okay. And therefore, we do the following thing. Ding, 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 ding. We go into... So, given a partition, well, let me be a little more be ahead of myself. I don't know what is the expression here. Anticipate. So in the end we're going to end up with a slightly more complex thing, namely, oh, that's still one group. I actually wanted to have two groups. But Nope. Nah, that's not working. Messing up my parentheses. This is one group, this is another group, and this was missing a parentheses. Apparently. Okay, so now I have a partition with 2 elements and 2 groups. And in order to implement our algorithm, I need to be able to figure out how many groups that thing has. Print groups, that's nice, but it's just printing it. I think gend will give it to me. Yeah, number of groups. Probably what I mean. What I meant. What I need. So I'm going to print that, and we're also going to print the number of groups. Just because. What else do I need to know? I need to know the number of elements that are in there, but probably not even stored in partition. It is assuming that you have all the elements in it. It's even declaring it like that. Yeah, so I have to keep that externally. The number of elements so far, well, doesn't work. Just call it n. It's 2. So yeah, A and B, 2 groups. Then the next step is, let's say we are here. This thing has, well, we are here. This has 2 groups. The total number of elements is 2. No, 4, or number of elements. So the depth is 4 minus 2. Yes? 1, 2. I think so. So at this point we're talking about the depth of number of elements minus n, which is 2. And then I want to get this this number. I don't know. Actually, I do not need the 10 here. I need if once I'm here. I need to know the number of partitions below this thing for each of those. Or now, when I'm here, I can maybe generate this thing. I probably have to do that, right? Yeah, I think I have to do that. So we are here, and then I'm generating this thing and this thing, partition. So at that point I'm really interested in this 10 here indeed. Okay, so that would be number of partitions. The number of groups. What is this? I'm just gonna use top groups. Comma depth. Totally random. Let's just use it everywhere. There's no way to flush the output. Yeah, well, I might as well. I'm using it 2 places. I could change this loop, I guess, to a group index. Even though it's the number of groups, right? This is a number of groups. It's not really, it's not even really a group index. A group index would be something that points into a group from an array. And even though this one returns that, actually I'm going to generate this thing, so probably I know the number of groups anyway without calling that. I'm going to call it also, make it a variable. I mean, I'm gonna make it a variable. So what is n here? N is the number of elements. Yeah, that's exactly what I wanted. 94,828. What's going wrong here? Oh, I'm passing 10 here instead of the expected 4. So actually it was what I wanted. Let's change number of elements to 4. Now it's printing 10 in accordance to my ASCII art. So that will be these 10 here. So next we need something that runs over all the partitions. Given a partition with elements, we want to generate all the partitions that has one element more. So in fact I want to add one element at a time, so I want to have a for loop that runs over the number of top elements. Now we begin with one top element, obviously. So inside this loop I'm going to add elements until the number of elements in the current root, I might as well call it top. I don't know, because I call this thing top, then it's kind of more logical to call this top. So the idea is I'm going to add elements to the top until we have a number of elements in it. And then we're done. So maybe I want to print that. I'm not sure if I've not already printed it, but I probably did, or maybe I did, I don't know. But yeah, I'm even flushing now. So refuse to flush my standard up. So we're going to generate a random partition, right? We begin with a single element. We're adding one element at a time. By the time we have all the elements we want, we print the result, and that will be my random partition. In order to do this, I need to generate all the partitions that we can get from the top partition. Or actually you don't need that, it's simply either we add the new element to one of the existing groups or we add it to a new group. So I should be able to do this like the only thing I need to know is well, the depth is a good one. The only thing I need to know is, I think, the number of... Yeah, I'm not going to generate my partition, I think. I'm going to generate a random number and then generate my partition afterwards. Because I don't care about the partitions, I just care about the number of groups in it. So, in order to get the number of partitions, I need to know the number of top groups and the depth. And the number of top groups is either equal to the number of top groups that we had if we add a new element in the same set, or one larger. Agreed. This is the same group is then the number of partitions that I will that are under branches where I add a new element to one of the existing groups. So the same group I used existing, let's use existing. So if I add my new element to an existing group, then after I did that, there are still going to be this many partitions below that. So each of those must get a weight equal to that. I add it to a new group, that branch will have this many partitions. However, I'm going to have multiple existing group branches, namely the number of groups, and the top groups times existing group plus the new group. Let's compare that with my table. Let me think. So I want top groups to be unequal 1. So I already am in AB. Okay, let's see if I can do that. So I'm already in AB. Yeah. So I'm calculating this number here, I think. I mean, that's what I should do. If we have 2, if we have 2 groups, then there are 3 partitions below that. And since we have 2 groups, the reason we have 2 groups after adding it to an existing group is because we started with 2 groups. So you have 2 groups. If then I add the next element, which is C, to an existing group, that is either to A or to B, set of, group of, then we end up, of course, with 1, 2 such partitions, so equal to the number of groups that we have in this partition. And each of these, which have start with 2 groups, generate after that 3 partitions. Therefore I must multiply 3 with 2, and then we get these 6. And then I add the number of partitions that are below a set with 3 groups, which is 4. So we get 2 times 3 is 6, plus 4 is 10. But it means that I need to apply the depth of 1 in this case on that number of groups, as well as here. I don't think I did it. Let's see, if now I start with A, top group is 1, top elements is 1, okay? Depth becomes 4 minus 1 is 3. Then we use a depth of 2. Total simply should become 15, I think, in this case, of everything. Depth. Just print all of it. Well, yeah, let's print total as well. Other people do this in the debugger, but I hate debuggers. Just debug output, I love it. Table. Yeah, something is not the way I wanted it. And that's of course because I'm not breaking here. There's nothing to loop yet. Well, this is where we start with. Yes, I agree. The number of groups is 1. I agree. Number of elements is 1. I agree. Depth is 3. That basically means we have to add 3 more elements. I agree. Existing group is 5. Well, yeah, that's correct. If we add this to, if we add the next element, which is B, to the existing group, so we get AB, then there's 5 possible partitions below that. So we are here. Existing group means we add this, and there are 5 elements, 5 partitions I mean below that. And if we add it to a new group, then there are 10 below that. Also printed. Total is 15, so now I can generate a random number between 1 and 15 and then decide which branch I want to take. Really, just something's wrong with my headset. It's probably this cable. Not good. If I have to replace that, probably have to replace it. I have to either replace it or fix it. Fixing it's possible, but you get such an ugly cable when I have to. I don't even know where the problem exactly is. They only sell this thing complete, which is very expensive. What if I just want to have the cable? Then you have to solder it. It's like $300. Well, I have also Bluetooth. $400. And I still have to solder it because I replaced the Limo plug. So I really don't want that. Yeah, I'm not just going to spend $400 on new thing here. Well, the only thing that's broken is the cable that I don't even want to show. I mean, that's on the other end of this thing here. Not good. Well, I'll have to generate a random number. It's always a lot of work. I probably should make that easier. Like make a utility. For example, if you look here, I already have that code, I think. Yeah, here. So this code would generate a seed, which is annoying. What is also annoying is that I have to create a new uniform int distribution for every range. Okay, then in the end we can just call this. I could make an object. Can make an object for all of this. Maybe, then at least I do not have to copy this code all the time. Let's do that, right? Yeah. My own class for, yeah, random numbers, I guess. I already have a random stream. Is that based on? It does use the twister. I don't think it generates a seed. Nope. Let's make a new class called random, and then I'm just calling it random number, even though I'm going to base it on the Gaussian twister. Yeah, shall I include a distribution in it? What is for gars? Okay, so I want to initialize it with or without a seed. If I do not pass a seed, then it must pick a random one. And I'm going to assume that this is a reasonable built-in type. Probably in just an unsigned long or something like that. And then I'll just use yeah, probably have to. I could use a default value of 0, but does not really make sense. Maybe. So this constructor then is doing initialize seed. With a random value. Yeah, let's do it in the CXX file. What I'm going to need an initial, might as well be public, void initialize seed. And there's not much to initialize, is there, or is there? This seed is being used to construct a thing. Can I reconstruct it? Put a new seed in it? Nobody knows. Set the current state of the engine. That's probably what I want then. Constructor. Default seed. Time to get curious about what this type is. This is standard machine engine. Why can I not find the result time on this page? Oh yeah, result type. The integral type generated by the engine. Results are undefined if this is not an unsigned integral type. That's the result. They take something completely different as a seed, it seems. Gonna look at the seed itself. Seed the engine with an unsigned int. I guess they take loads of information, like it's a template and they just accept anything, including an int. Don't understand why this is passed as a reference. Yeah, the result type is being used as well. You are allowed to seed it with the result type or with anything else apparently. There's a standard seed sequence. Which exists of an apparently of a vector or array or something like that with unsigned integers of 32 bits. Okay, so this code here generates a result type as seed and only a result type as seed. But now I'm putting in my utils library. I want to make it. I want to do it the right way. So we have to support all the possible seeds. Which means I don't think I can even store an intermediate state. You just have to call seed. So I can accept this type, and then we just call seed on the twister. This stands for seed sequence, I guess. Can as well just call it seed. Oh wait, if I call it seat, then I cannot call this one seat. They really allow this separately, either by seed sequence reference or result type. So now I have to be able to do this, but I can't or don't store the distribution inside this object, so I have to turn it around, I think, to recall a member function on the generator, or actually on my random number generator with a uniform distribution. Could also make that allow more there. What is this anyway? This int. It's the result, I guess. Yeah, okay. Okay, so we allow to pass a uniform int distribution. I guess that must be an integral. Gonna try if this can pass it as a constant reference. Okay, I don't know, it's probably all wrong. Especially this one. Does it even exist, or how does it work again? Got that. Integral constant is integral. No, it's the old way of doing things. Test that more. Unsigned integral. That's at least the concept. Could use that one. But we must also be able to generate negative numbers, right? So is that standard integral something, or what is it? Is it is integral? This one maybe? It's not a concept. This is just standard integral. Yeah. Well, we can do this one inlined, of course, and then the seed I still have to write. Oh no, actually I do not. This one is the only one that's not inlined. Random nummer. Well, I don't even think I need a random device in the object, because this is basically going to generate my seed. So we also do not need grow now here then. think it's time to test using it. What the hell did I add it to? Thought I was adding it to this one. Add to partitions. Okay. So how does the thing work? I can print now a random number by saying rn.generate, and then I have to pass a distribution, and the distribution is still standard uniform int distribution, I think. Well, let's try long and then between distribution between -5 and 10. Då match we call to standard uniform int distribution long int. Candidate. I think I should go eat, because I don't see it anymore. What is this? In instantiation of int utils random number generate const standard uniform int distribution int type reference with int as long int. Required from here. Error no match for call to standard uniform int distribution long int. Yeah, I would say problem is that this is not const. Hmm. So it prints entering random number with a pointer to this pointer, prints a seed. And I'm not, oh, and then it prints 8. I guess it should print a few of those things. Well, it looks like it works. So to start with 8, 8 minus 2, and run it again. You get something else, and that's also possible to repeat this. It's 10 minus 2, 5. Ten minus 2, 5. Okay, well, it's good enough for me until it stops working. For now, as it were. Right. I think that should do it, right? You can still compile this. Cannot. Utils random number and does now not have. Oh, I called it generate. Yeah, well, we can change that. Why shall I just not do that? I think it's generate. Okay. Audrey said, how can you remember all these commands? Which commands? Yeah, I don't think we can pass it temporarily to a non-cons reference. Which is why, really? Why did it have to be a reference? But, okay, let's try it anyway. Standard uniform distribution. And the number that we want to get is of this type. Make it. Right. So that would be cool. I really should switch to using libcwd for this output. If only to get rid of all these backslash ins. And the number is not a member of utils, seriously? Hey bear. How is my bear? Utils random number. Probably need to include it. Just got a feeling like it. Utils random number dot h. Int distribution. Hey, good to see you. What is this? It's not compiling because non-const. Yeah, that's what I said. This doesn't work. I think that's kind of strange. Well, I have to generate a number from 1 or from 0. What is it? Yeah, there's no problem. No problem at all, man. Although I mean, I didn't know if you were still here, so I just clicked on it. Because I saw it. I forgot again if the uniform in distribution is inclusive or not. I think it is inclusive. I want to start at 0 anyway. So total minus 1 then. But it doesn't want to take temporary. I wonder why not. I'm doing something horribly wrong here by reconstructing my distribution over and over and over. I mean, the total is continuously changing, so what can we do? Random number is 10. Random number is 11, 12, 2, 4, 2, 8. Absolutely, totally random. I guess it is random. Okay. Now I want to see a 1 at some time. Maybe a 0 even. 14. Zero. I saw a 0. We are not seeing 15s. Of course we don't see 15s. It's already inclusive with 14. So this is generating number 0 up till and including 14. And then we have to decide which branch to take. Okay. Let's be dumb. Suppose we generate a number 3 times 3, or the top group is 3, existing group is 3, 3 times 3 plus 4. Then we are in this range when our generated number is less than 9, where 9 is equal to this multiplication. If my random number n is less than top groups times existing groups, then we have to add it to an existing group. Else we have to add it to its own group. That should be a lot easier, and so let's do that. Now let's turn it around. Okay, well, that should be easy. First we need the element. What is the element? Element, new element. Actually, I can create that before this. Where can I create my new element? I think here. So we have this many elements in the top already. Say there is 1 in it, then I want 1 to generate B. And I can create elements from characters. So this is just simply A plus top elements. So if there is 1 in the top element, which is initially the case, then we get A plus 1 is B. And so my new element is B. I'm not going to change that. I could add const everywhere. So depth is not changing, nothing is changing. So now I have to add my new element to a new group. Having partition. Top. Add new element to a new group. I forgot, of course, how that works, even though I wrote all the code. Partition does have the following. So it doesn't allow adding anything at all. Well, I have to add something then to it. So what I want is create a new group. Well, the group already exists. It's just empty. All I need is a group index and an element. Or a group. Or a group created from an element. So we want to say add group to group index whatever. I think that a funny thing of the way I'm sorting it now is that if I add a new element, I do not have to resort. How is that possible? Cannot possibly change the sorting. How awesome is that? Yeah. Well, funny. I was just thinking ahead, but okay, so we don't have to do that. I can just do add, let's call it add to. And now we begin with what we want to add, which is then a group. No, then we have to resort. Okay, that's it. Kind of shitty. I don't want to resort. I'll add a new element. Hell, do not know already what the last element is then. I don't think we know that really. I mean, I could figure it out by running over all the groups, but isn't that a bit idiotic? Just to limit the API of this thing. Okay, we have a sort as well. Let's put the responsibility to the caller. Oops. Well, yeah, that's working. The caller is going to add a whole group then, and we'll call that group, I guess. And now we have a group index where to add it to. And I also call that group, usually. Really? Is that what we do? No, call it group index. Groups is an array and which takes group index, and then we can just add my group like that. It's a bit mask. At least I think so, and it's probably faster to know for sure by trying to compile it. No match for operator. Group does not know how to add it or itself with it. Why not? Is the question. We have an add. That would do. Add, remove, toggle. Yeah, okay, let's have to use add. We're going to add new element, which must be a group, but I created an element. However, since add 2 takes a group, add 2 takes a group, and group can be non-explicitly constructed from an element. That will work. And then a second argument, I need to pass a group index. So this group index is going to be the new element, right? So equal to top elements. For example, if top element is 1, then we want to add it to not to 0, but to group 1. However, you have to do that explicitly because you cannot implicitly construct a group index from an integer. This is an array index thing which can be constructed explicitly from an int, but explicit means that you have to really spell it out, like I want this. So in this case I really spell it out. I have an int, but I really want a group index, and then we can pass that to a function that takes a group index. And now we still have to implement this one. Almost the same line. You start to wonder if maybe you can combine them, because we still want to add to top and we still want to add a new element, but now we don't want to add it to top elements anymore. We want to add it to, well, now n is less than top groups times existing groups, so you can guess it. N divided by existing groups, which runs from 0 all the way up to top groups minus 1. Now you could even use this line for this one, except that the number of new group, this new group's value here, might be larger than the existing group's value. So then that would go wrong. I would have to set a maximum. And it's less logical, so I might as well do it like this. Okay, so now we update it according to our random number, the partition top. We no longer want to break, we want to continue, happily continue with the next thing. So top elements must be incremented. We just added the top element, which then means that top groups must be updated. So obviously only when we add it to an new group, the number of groups in top becomes larger. And then we get the next element. The depth is one less. We get the existing groups from that point, the new groups from that point, the total. We print a lot of stuff. And we make our new distribution, generate a new generated zip. It works. Okay, so zip make works. You cannot divide that. Warning, narrowing conversion. What exactly is narrowing here? I guess it's narrowing when we go to group index. Okay. Well, this value here is less than. After division, we have something that is definitely less than top groups, which is an integer. So it doesn't have to whine. It should not whine. Stop whining. Static. Do not whine. Int. Don't tell me it's going to complain about narrowing conversions when I use static cast. It's not. Okay. Isn't it awesome? We start with A. We have 15 possibilities in total. We have to decide between splitting branch with 5 or 10. We generate 6, which means that we not pick the first 5, we pick the 10. AKA, we add B to its own group. So now we have 2 groups, we have 2 elements obviously. The depth is 1 less. Existing groups is 3. Okay, and here was it 5. Oh, right. So partitions. The number of partitions when I add the element to an existing group. See, it ends on the same 2 words. There's now 3 and 4 when we add it to its own group. Total is 10. That's why those 10. Yep. Random number 7 is again larger than. It's not larger than. Is it larger than? Wait, existing group. Yeah, it's not clear, but it's 2 times 3 is the 6. 7 is larger than that 6, therefore we go for the new group. So it's again added to a new group. Now we have 3 groups, 3 elements, the depth is reduced again. And now there is, if you add it to an existing group, then we're just done. There's 1 left. If you add it to a new group, idem dito, it's always 1. Total is 4, the random number is 1, so we do add it not to A, which would be correspond to 0, but we add it to group number 1. So this the random number is literally added to 0 is here, 1 is here, 2 is here, and 3 would have been adding it at the end. I hope. I'm gonna run it a few times now. Okay, it's not working. Suddenly our D has disappeared. No D. It worked up till here. Check it again. Okay, 1, 2, 14. To be the maximum. 1 less than that. That's, we also do that here. Strange. So the total of 3 means I think top groups times 1 plus 1. Random number is all the end. It should have generated A, B, C, and then D. Didn't. Why is that? It's really strange. There's something else missing. I didn't print out the seed. I cannot reproduce it. It's not printing out a seed because I did not add support for libcwd. At the top of main, you have to do that. Yeah, here C is missing. Might as well work with that. Well, I think I have a theory. I think it adds it to the end. So as soon as we have a set, so you have A, B, C, and then D is added there. Well, even A, B, C, D we should get at some point. This is a chance of 1 in 15. Give me it. Give it to me. Yeah, there it is. So, yeah. Oh, well, this one is nice. C, both C and D are gone. Well, I think I know what it is. That is, I see what it is, but I don't see yet what the error in the code then is. I don't remember having made a mistake. Oh, yeah. Stares you in the face. Top groups. Consider it a typo. I would never have made a mistake if I had my mind with it. Now, and then to really test it, you have to stop printing all the shit in between and just count the number of partitions, make a histogram. So this is the debug output is a bit over the top. I think I killed it all, right? Pretty much. So I could put all of this inside a big loop. Start over and over from here. Okay, let's start smaller. Too enthusiastic because I'm still printing this. I don't even have to write code for it. I can just use the bash, the output. So we can go straight to, let me first check it, but we can go straight to 1,000,000 and then just check it. So these are 100 different partitions that are generated randomly. And let's go to, that seems to work, right? Let's go to 1,000,000. That's 1,000,000. Okay, make. And let's not print it. I have to really resist myself hitting enter. Ah, I hit enter. Okay. Try to file. How long is that's not long. Then we do sort. That's the big trick. Sort through. Then we do unique counts, and then sort in. Why not? Oh, it looks like it worked, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So all partitions are generated. And here you see how often they were generated. So that's hardly any variation, aka a uniform distribution. And it's definitely not the case that ADBC is going to be at the bottom every time. So we'll run it again. Okay, all the numbers are exactly the same. The same seed is used. Why the hell is the same seed being used? What? That's exactly. Oh, someone kill me. Like I was saying, it's not like ADBC is going to be all the time at the bottom. It's now here. This is just nice uniformly distributed. But yes, cracking my fingers. Now we go to elemental H and change it from 4 to whatever we want, right? I'll start with 8. Just double it. Let's not forget to run this. Dude, it takes considerably longer. Well, now we have a lot of partitions, and each partition has been generated almost 300 plus. There's a pretty big difference there. Yeah, I don't know how many there are. Probably too many. Okay, so what I can do is just print the top and the bottom of this. That output is not what I would have expected. I print the first 5 lines and the last 5 lines, so that should be 10 lines, right? Why am I only seeing 1, 2? Oh, it counted these as the first lines. So these are the first 5 lines. Yeah, right. Okay, let's add 3 then. Yeah, that's a big change, but this is also a pretty small number. 188, 294. It's pretty consistent in the maximum number of times I was saying. Now it's 297 only. 181. Sure, this is a big spread. But I'm kind of convinced that it works-ish. Let's say I would totally be convinced if I see really different partitions appear at the top and the bottom. Yeah, okay, that's pretty good, I think. Pretty good differences. It has to be. Takes a few seconds, huh? So I want to do this, but then we have to take many minutes, which is exactly enough time for me to eat something. I'm going to eat something. Be back later. Still not done. Kind of strange. My browser is gone. Yep, no browser. Looks like Chromium crashed while I was away. Let's launch it again. Right, Lilo Mandela asked if you can get a very good job as a C++ programmer if you have no experience as a 21-year-old, but you are good at C++. I think I'm not the right person to answer that. But I can give my opinion, but just my personal opinion, don't hang yourself on it. I would guess that anyone who hires you wants some kind of proof that you're good. And of course, if you have a lot of experience on previous jobs or whatever, or maybe open source if you're that young. But yeah, I don't think you have to go for a good job. You should go for any job. Any job as C++ programmer would be wonderful. And then show them that you are very good. And then after say 2 or 3 years, you can look for another job. Maybe a little bit better, a higher pay, and so on. And then by the time you're 30 or 32-ish, 10 years later, then you have your good job. If you keep looking. But well, that's just my opinion. Right. So I have my partitioning, random partitioning generator now. And then I can start to use it inside this program. My god, I even forgot what this program is doing. Just because I worked 2 days on something else. Scary. Hello, ones and zeros. There is progress. But I just literally forgot what my partitions program was doing, or where I was. Alright, I printed this. This was in an attempt. There was in an attempt to do what I now did, although in a different way. So I don't need this anymore. But what did it do before that? Okay, we have a tree, run over brute force over all possible partitions, and we print out the generated partitions with a certain structure. I forgot what tree was. Tree is literally what we're printing. Yeah, not interested in that anymore, I think. Just delete all of this, see what we get. What we did before that. I'm quite serious about not wanting tree anymore. Yeah. Right. Yeah. Now this is what I was doing, yeah. To generate the partitions, the brute force, and then from every partition I run my algorithm and I count how often I get stuck on the local maximum. Or the real maximum. So I can find the real maximum, I think, by just generating random partitions and then finding a local maximum, and then the maximum of the local maxima that I find is probably the real maximum if I generate enough random partitions. And I need to have the real solution, which I can find that way, to test an even more sophisticated algorithm. So this gives me this is brute force, so this is definitely 100% the right solution. But that's not with a lot of elements. So if I make the number of elements larger, then it's going to be more statistical. I need a more statistical way to find it. If I generate 1,000 random partitions, then it's extremely unlikely, I think, that I do not find the most optimal solution. Although it depends a bit on the number of local maxima that I have. So I think that what I want to do is I want to not run brute force over everything. I just want to run over a number of random partitions and then count just those, right? Yeah. This is the algorithm already. Oh, here's my brute force loop. So I'm running of the brute force loop. Instead of doing that, I just want to run over random partitions now. I think I can do that by what is stored in results? Well, that's the final, the local maxima saying that we end up in. Yeah, good. If I generate a random partition and I generate the same partition twice, that's unlikely. Like it's a no care. So let's replace this. The BI is way too short. I think this is the last place where it is being used. Yep. So what I'm going to do instead is replace this with some kind of I don't know. Let's call it RP. It runs over the over random partitions. RP counter. But well, okay. And then here we must generate a random partition. Any random partition. Well, how did that work? If I just do a partition column random, that returns a random partition. It's just, you see that by the name alone. So now I have to add random to partition. And now we have to implement it. Oh, oops, you have to implement it. Dang. Well, I'm going to steal that from my table. Yeah. What happens? Everything saved. So I was storing something in partition.cxx and I'm gonna steal it from table. Because this thing is generating random stuff. Should I not just make a function here that does it and then call that to keep it in this file? want to have something like partition random. I mean, this does what I want. Can I turn it into a class more-ish? For example, now I'm creating random number over and over. That's definitely not the idea. Therefore, we have to put this now outside and make it a global, which is absolute horror. Don't want to have global variables. Either that, or I just don't make a new class, but I put everything in partition. I guess you can do that. I'll just do that. So we're going to get rid of this whole file and then move everything over to. So I delete this. Printing tables. Could make it a static function. And let's pass top groups. Yeah, well, maybe not a static function of just a free function. Just to keep it around. Will C++ be enough to stop human civilization from catastrophe? No. Humans are so stupid, it's unbelievable. I mean, today I heard like there's literally a chance for nuclear war at the moment. Like 1 in 5. Well, I don't know, but let's make it 1 in 6. So you just throw a die. And then it's gonna happen again and again and again and again. And eventually you will throw that 6. That's why we have to, we should have been on Mars already. I think it's really sad. And it happened before, right? Politicians doing the game. We have been multiple times on the very edge of a complete annihilation because of a nuclear war breaking out, which then was stopped not by someone at the top, but by someone who were just, you know, just one person somewhere halfway who just thought to himself, I'm not going to start a nuclear war, I'm not going to follow orders, something like that. Very close. We have been, in fact, at some point, you know, America and Russia were making more and more atomic weapons until they could destroy the whole world over many times. And at some point they started to negotiate to break down the nuclear weapons and get rid of it. Now guess one time why they started doing that. They did that because it almost happened. They scared themselves. Like, oh shit, you know, it's not a game. It's going to happen. We have to get rid of these weapons, or it's going to happen one day. But now it's decades later, and I think they are starting to make the nuclear weapons again. I don't know. People are crazy. I mean, everyone can see that Biden is crazy, but that's the kind of guys that we give the keys to our nuclear weapons. Really. I don't know about Putin, but if Putin starts to use tactical nuclear weapons, then you can say he's not rational. Why on earth would he do that? But you can also say, how is the rest of the world going to react? Are they going to react rational? Rational would be putting your hands in the air and say, okay, dude, put in whatever you want. That would be rational. Otherwise everyone loses. And I'm pretty sure they would not do that. If a few small nuclear weapons are being used in the Ukraine, the chance is fucking big that some complete military idiot who thinks that everything is about fighting is going to scream, nuke them all! And then all the rockets go into the air, and that's the end of humanity. I think it's really, really sad. Nobody should have such weapons. So I am kind of in favor for that reason to get a world government. I'm super against this whole globalization shit and all the lying and all the money corruption. But if it means that we get a single world government so that nobody has to worry anymore about complete idiots starting a nuclear war, yeah, that's probably the best thing then. You see it already, right? Wasn't it Elon Musk that tweeted something which he thought was a way to get out of, to de-escalate the war between Russia and Ukraine. And a few important people just basically said fuck off. As if they didn't want the peace. They're not thinking rationally. They just want what they want, and they do not want you to put water in the wine or whatever. And in the meantime, many humans are dying already in this war, let alone if it escalates. I lived in the time of the Cold War, where America and Russia had many atomic weapons, and the button could be pressed any moment. That lasted like a few decades, and like I just said, and now we know, decades later we know that it went wrong almost a few times. And it is something that is constantly above your head. I don't want that back. I don't want to live again in a world where I don't know if you know, tomorrow I hear on the radio that the Third World War has broken out. Scary shit. Especially sad. I'm sitting here with tears in my eyes, just thinking about if this happens. I wouldn't be scared for me personally. I would just be extremely sad for humanity. We have this beautiful future where we colonize the whole Milky Way, thousands of planets, billions times billions of humans go live through their lives and have romance and live all those things. The whole future is the possible future is way larger than what humanity has done until now. And we destroy ourselves. You throw away maybe 1 million times what humanity has gone through till now. So all the science fiction books and all the unwritten science fiction books about what humanity will do and can do in the future, it's all going to be pure fiction and never become reality. And that probably is then the guilt of a few people, just a few. How can that be? But okay, this makes me so sad. Let's really just not think about it. Cannot do anything about it anyway. Well, we could, you know, the masses could. If we have enough people, then we have the voice. If literally in all of Europe, millions of people would go on the street shouting that they want to stop supporting this war, because the war is lasting, among other things, because the NATO just keeps giving weapons, and they keep giving weapons. And okay, it works between quotes, because Russia is now losing, apparently, or at least they have it very difficult. But you're throwing dice with that. Why not just, you know, stop giving weapons, sit around this table and do whatever it takes to stop the war? And then there are a few powerful politicians that say no. I think these protests are already happening in France, I heard. And they're just being ignored by the people in charge. What the fuck, man? I'm amazed that the number of viewers didn't drop down since I started talking about it. But well. Print table. Yeah, okay. So I wanted to move all of table.cxx to partition.cxx. This is the most important one. Yeah, oh yeah, it's a well-known saying also, isn't it? If it goes economically really bad with a country, then one of the ways to get out of it is to start a war. As long as we don't destroy all of humanity, it's apparently not that bad. Apart from the country where the war is held, of course. Ukrainian people don't like this, but Maybe they really all do it on purpose, just to, you know, because it's good for economy or whatever. There you have it, the answer to life, the universe and the rest. I just deleted it. See the bottom left corner. But I paste it back. Ta-da, ta-da-da-da-da-da. Okay, so this is the attempt then. Now of course this does not work because we do not have here number of partitions, which is defined here. So I'm going to have to copy this as well. And that one uses table, and that one uses and so on and so on and so on. Might as well copy everything. Okay, it does everything. The whole file is now gone. And we need that somewhere above here. Well, I'm okay with this thing here being local, right? So it's a local thing in a .cxx file, I mean. Array as well, number of partitions, yeah, why not? I could put all of this actually in the anonymous namespace. Namespace anonymous. Table, number of partitions, even the random number generator could be there. And we end that here. And then we add this to partition. Already added that. Well, in that case. And we're just going to delete all of this. Although actually I probably need to copy this one. Yeah, maybe another one as well, I don't know. Don't have this anymore. Random number. Do not have a table.h, so that was it. Now let's see what all goes wrong here. What? Oh, what? I think it's terminated. Table.cxx. Oh, the whole table is gone. No more table. Yep. Missing header file, IO manip. Typos. That was quick. So now we do not brute force, but only for 1000 random partitions. I'm interested in what this does. Partitions. Oh, so disappointing. Wait, this is with a certain seed. Oh no, I cannot find the previous seed back, I bet. I can. So this one had 1, 2, 3, 4. 3 local maxima, I mean, and 1 real maxima using this seed. Let's try that again. Passing the same seed. Oh, it is a probably nonsensical tender. So nonsensical? Yeah, I don't think it is gonna work. It is. Is it really going to work? So I have here 5, 1, 100 minus infinity, 5 minus 100 minus 100. Yep, that's the same thing. And then here we have a D, CF and B at the end extra. How can I remember this? Probably not. Yeah, it's the same. Well, that's awesome. But means that the best solution is there, right? I mean, this is 100% sure the best solution. And there are 750 partitions that end up in the right solution. And from those 750, we randomly generated by accident 199. So the chance that we generate 0 of them is super small, really. Like, will never happen. And I think the same should hold with a larger number. So now again all the way up. I think 12 is still doable, but already significantly slow. No more slow. But now you see that we have only 3 here. Whoa, yeah, that's so if the best solution that it found now is 713, which happens to have 639 hits. But what if the one of the other ones was the maximum? What if this was the maximum? Then we barely found it. So I think it would be safer to increase the number of random values, like drastically in this case. In J or something. No. It was RP. 100 times more. Is that too much? Yeah, okay, it's too much. try 1/10 of that. Well, it's still 713, which happens to be hit a lot. I'm guessing that this is the actual solution. Well, it seems that we're still having a problem. PFT. I need to know your honest opinion on the current topic. I do not see any chat from you before that. Can you enlighten me what the current topic is? I was going to edit element.h. I'll make this huge. Cannot make it huge. Cannot. Impossible. 30. Yeah, it doesn't even compile. That's what I mean. What? Why does it not compile? Well, I guess we have an overflow somewhere. I think we have an overflow. Oops. Can't say that's very clear what the overflow is, but oh, I see the overflow. 16 bits. Let's make this 32. Duh. 30 elements. How long is this going to take? That's a table. Yeah, it takes longer than I thought. So I stop it and print the number of partitions that it already did. Let's try this again. And yes, now we need flushing. Finally, we really need flushing. You know, while I'm at it, I'm going to print all the stuff that we just made. So it is in the current partition and the score. Because man wants to see something happening to ponder about. Hey, there we go. So this is going to continue until 10,000. I probably stopped it at 9,998. Seems to be doable. It's kind of slow-ish, I have to say. Looks like generates 20 partitions per second or so. No more. $25. $10,000 divided by 25 is 400, right? $400 seconds. That's a lot of minutes, but we're already halfway. So I'm gonna wait it out. The only really bad thing that could happen now, apart from a bright flash outside, is that we get to 10,000 and then it turned out that I accidentally missed a zero, and it's going to continue till 100,000. Then we have to stop it anyway. $666. I knew it would happen, but I just, yeah, let it happen. I just let it happen. But in the meantime, we have reached the 7,000. Imagine that this is the year that you that we live in. You're still living. The year 7,777 just passed. Big celebration that year. Okay, we're almost there. I guess it's not the random partition that takes time, it is finding the solution of the maxima that takes time. It's my algorithm. I think the generation of the random partition is pretty fast. Okay. So the maximum is 331 something. 3316 with 2 times plus infinity. All the maxima I bet have 2 times infinity. They better have. Oh, I even get all the maxima in my scroll back, easily even. There are not that many. It's pretty cool. But still, with 10,000 random partitionings, we only have one. I mean, this is, yeah, one that leads to this particular local maximum. So it was not a big chance to find this one. I can imagine we missed certain local maxima, and then that means of course that we could miss the real maximum. Why didn't I see it, by the way? There it is. Only 3, holy moly. So if we did not generate one of these 3, we would not have found this maximum. That's not really working, is it? That's not what I call working. But then again, 30 is really a lot. Let's switch to 26 because all the weird characters are, I don't like that. And switch to compiling with optimization. Curious. Maybe using this? Oh yeah, of course I'm using it. Map, it's not being used here. That is hardly faster. It's definitely not faster. It's slower, isn't it? Like much slower. How the F is that possible? Like twice as slow. Huh? What? Okay, let's not print the partitions because that might slow us down, maybe still. So I'm going to print just the RP value. Yep, really is very slow. The generation of the random numbers was significantly faster, but this is not fast. I don't feel like waiting till 10,000 again. It just takes too long. It is way too fast. Slow, I mean. I was planning to use 1,000,000 for my test, but that would be even 100 times slower than this. So then I would have to run a few hours. Why is this being so slow? Now I want to benchmark it. No word spends all the time. This is the same seed, right? So it's just exactly the same thing. So we should again find 3,316 plus 2 times infinity. That means I'm going to let it run again till the end. In the meantime, I could do something else. Like So curious, how is it possible that this got slower when I compile it with optimization on? That's like, whoa. I have no idea what you're saying. Yeah, halfway. Let's lose another game with chess in the meantime. Seriously? It held. Oh, it didn't. I want my knight here. So hardly an option. That would be 4 moves. And that too then, I guess. 1, 2, 3, 4. Might as well go through this one. But how? That would be like I have to move my queen and my rook first. And I would go here and he might take my rook. Oh no. What if I first double my rooks? It's not possible because there's a knight here. Therefore, if I chase away the rook, so chase away the knight, it goes here. Hey, that blocks the rook. Then I can go here with my knight. Okay, maybe he plays this. I'll just take it. There's nothing I can do about that anyway. He's going here, I guess then. Why? No squares whatsoever, unless he wants to sacrifice here. So suppose I move here, and he goes there, and I go here. And then he takes here, and I take, and he takes, and then I take there, and I just have... just point up or something? I don't know. Definitely wants to sacrifice here. Now he threatens to take it because my pawn is pinned. But hey, What if I move just here, which I wanted to do? Get rid of my bad bishop. Oh, he's threatening it again. And he takes with check. I could defend it with my knight, but suppose he just takes that, and I take it back with my rook, and then he takes with his knight. Then I lose a pawn. He gives a quality. No, he it's just a rook exchange here. If I put my king to the side, and he takes here, and I take back, and he takes again, I can put my knight in between. That would work. The elo is displayed here, but well, I don't think I'm that high-ish. On my main account, I've dropped a lot lately. I think I'm now 1930 on my main account. This one has dropped a lot as well. It used to be over 2100 here, but usually not winning. Plus it's a light chess. Light chess is like 500 points higher than well, no, it's 500 is not. I think my real life rating, yeah, for slow games, well, maybe it is 500 points. For standard games, it is. My pawn hangs if I go there. It's maybe 1900. So for a 5-minute game, I have to play faster. Probably should go here and then put the rook here. Or I can go here and defend my pawn. But that seems pretty passive-ish. Yeah, and I gave away a rook if I do that. Begun with the queen. I'm using Arch Linux. I'm up 1 pawn. Shouldn't I be winning this? One, two, three, 1, 2, 3. Let's get out of the pinning. My knight can't move, but it can move at the last take. He can go to the side because I'm pinned here. But if I move my king, so my knight is unpinned. If he goes to the side, I take here with check. So that's probably not a good idea for him. But I think I want to go to the side anyway, or just take here twice. He has only 12 seconds left. Probably now afraid to lose on time. Okay. I'm a knight up. I'm completely winning. Why is he not resigning? I think he thinks that maybe he can win on... okay, it's annoying. It is definitely annoying. If I go here and he walks, I can stop him with my knight. Probably better. I totally not convinced myself with this. If I go here with my knight and he promotes, then he can come in, right? It's definitely too scary. I'm gonna do it anyway. So now he wants to take my stuff. Now he resigns. Still not. I'm gonna take a bishop. Offers a draw. Keep on playing. I'll take a bishop. Damn it. Well, that was fun. There we are. Maximum score of 5,400. That's like the what? Is it not the same thing as we had before? Confused. No, it cannot be the same thing. It was exactly the same. It would have been 3,316. So, okay, so man, those are a lot of local minima. I had a plan to reduce the number of local minima drastically, but I wanted to write code first that gives me the Dude, I'm just clicking on search here. Bleep. This one. Go down, go up. There it is. 1. I think we might have missed it before. If it is the same scores, which I don't know now, of course. Oh my god, a local minimum with a negative infinity in it. That's pretty unbelievable. You get to see weird things, apparently, with a lot of elements. Oh, there is something else I can do. If we just randomly generate 1,000 different partitions and then I run my algorithm and all 1,000 give the same maximum, then that's probably the answer. If there are multiple different answers, which is likely, it's extremely likely in the case that we miss the correct answer, I know for a fact that all but one are local maxima. So let's say, well, literally all of these partitions that you see here, know for sure that all of them, except that the one that has a maximum value, are local. So what I could do is that for all of those local maxima, I can try to find another maxima by running algorithm 3. Whatever that is, I still have to make it up then, but... And that would be a lot of shaking. Antonio, yeah. It seems that many people think that for some reason. Which surprises me, I have to say. But, yeah. Hilario asks, have you tried a binary search tree? I don't think that helps. I mean, if you have a binary search tree, that means that you need to know if at every branch, which branch leads to the correct answer. But there's no way we know that. We can know that. There are billions of possible solutions. I mean, it's already known. It's an NP incomplete problem. So there is not even there does simply not exist an algorithm for this that can solve it in polynomial time. The best we can do is search for something that is approximately very good in a pretty short time by using certain heuristics. Still not very convinced that we find the best solution this way when the counts are all one or two. How many different maxima did it find? Local maxima. So really the first step is to reduce the number of maxima, aka improve my algorithm. I think I'm gonna stop for today, however, because I'm gonna do something else and I have to really eat. Like I said yesterday when I left the stream at a more reasonable time than today, I bought vegetables and they're just getting overdated. So I need to empty my my fridge by now, by cooking every day. So I'm going to cook my dinner. Okay. Thank you for being here, and I'll wish you a good day for the rest of the day, and I'll see you tomorrow.